But now I'd like to introduce IonQ Tempo, our next generation system with AQ 64. An unimaginable 18 quintillion different computational space that you can use with this system. This one, substantially smaller again, fitting in roughly 3 racks. So a huge size reduction from the previous generation. This is a monster of a machine. This is the machine that I joined for, to be able to show real value to customers with a quantum computer that's actually powerful enough to deliver that. And that's this machine. And also in Switzerland, they bought 2 generations of systems. So they bought a Forte Enterprise. And today you can see the second system, which is an AQ 64 system. And this one roughly is about 34 billion times more powerful than the previous generation of Forte Enterprise. And I'll say a little cheekily that if you don't have one of these, then you're probably falling behind. So we encourage people to be able to get access to this. We will look to start producing many of these to be able to hit customer demand. And as I mentioned, about half the company now is working on manufacturability of quantum computing and reducing the cost. I want to just talk a little about, you've heard our AQ numbers. The AQ numbers are based on benchmarks that the QEDC put together. It's a series of application benchmarks. And so I wanted to just talk about kind of how this scales. Of course, it scales exponentially. You've all heard that every time you add a good enough qubit, not just a physical qubit, one that has enough low error, that you double the computational power of the quantum computer. Quantum computing grows exponentially to numbers very quickly. We're going to be outside of your vocabulary. Actually, my guess is today we will talk about numbers that you've never heard about before. And going forward, that will be the case all the time. And in fact, actually, we'll get to a place where we need to come up with new names for some of the computational power of quantum computing. I'll suggest one today. So what this slide is trying to do is represent the growth of the computational space of a quantum computer. So if you were to consider AQ5, that it would be roughly, our analogy is the tip of a magic marker. And generally the circuits that you can run is about 25 entangling gates. So because after that, what happens is the error rate starts to come in and stop you from running larger circuits. So if you had AQ5, our analogy is about 10 millimeters. If you had AQ29, suddenly you would have the surface area of a basketball. And this is the system that we just released recently. So at the same time, AQ 64 is about, well, it's a little bit bigger than the United States. It's about 10 quintillion squared millimeters. Or in other words, is AQ 64 is about 30 billion times larger than AQ 29. The computational space of AQ 64 is 2 to the 64. And that's roughly 18 quintillion. And to put that in perspective, Frontier's supercomputer at Oak Ridge National Laboratories calculates about 1.2 quintillion floating point operations per second.